We are going to attempt to find maximum or minimum values of this function if available. So what we are going to use is fundamental theorem of calculus, which tells us that the derivative of function defined by a definite integral in this manner is given by this formula. And in this case, we have a slight symbolic variation that our t and x, they're just switched with each other. So our formula also changes to a different format. Okay, that is the derivative of capital F is the small f as functions of t. Okay, so let's just go back to our original question. That is to find the min or max values of this function. So what we would do first is that we shall take the derivative in order to try to find the critical points. So what we would do, we will set let's set this equal to 0. And since this quantity in the denominator is never 0, actually it's always positive. So what we get is, we get that this quantity will have to be 0, right? And if we use the quadratic formula on t square minus 2t minus 1, what we shall get is that t will be 1 and then plus or minus square root of 2. Okay, so the two critical numbers that we have in here are 1 minus negative square root of 2 and 1 plus square root of 2. So we can either do like increasing decreasing analysis, or we can just go ahead and calculate the second derivative of f and do the concavity test, and that might help us for further matters also. So when I am doing when I'm finding the second derivative, what I'm doing is that I took the first derivative and then I'm taking the derivative of this function. Sorry, I shouldn't have left it unattended like that. So then I'm just using the quotient rule. Okay, so the quotient rule will do what? Just square the denominator for you. All right. And then the derivative of the numerator is 2t minus 2 times t squared plus 1, the denominator, and then minus the derivative of the denominator, that is simply 2t, and then times how much? Times this numerator. Okay. And then you can see right here, when you go ahead and simplify it, this 2t times t squared is 2t cube, which will cancel the 2t cube in here. Okay, so what we shall have is, then we shall have negative 2 times t squared is negative 2t squared. Okay, and so when you simplify it, okay, what you see here is that you see a 4t squared coming in here. Negative 2t times negative 2t is positive 4t squared. And then for t's, I get a 2t here. And then I get, negative 2t here. And then I get a positive 4t here. And then a 2t here. So that gives us a total of how many? 4 t's, right? Okay, and then we get what? Negative 2 times plus 1 is negative 2, and the denominator is simply the same as that. Sorry for boring you with so much algebra. Okay, all right, so here we go. So the whole thing becomes 2t squared plus 4t minus 2, or we can just factor a 2 out. I mean, we could have done just the sign analysis of the first derivative, and that would have given us the max and min, and we don't have to find the concavity answers here, but we are working on it anyways. So this is the second derivative. And as you can see, that if we look at the second derivative, and if you obtain the second derivative at 1 minus square root of 2, you can easily see that at 1 minus square root of 2, this quantity will be how much? This quantity will be a negative quantity. I'll just leave it for you to verify. Okay. All right. That is at this point, the second derivative is negative. So what happens is that we shall have a local min here, local max here, because the function is concave down, and this quantity here, if we put t equals 1 plus square root of 2, so here, just and note that if we substitute, t equals 1 plus square root of 2, that is about 2.41, then this would be greater than 0, and we shall have a local max here. Okay, now let's just go ahead, local min here, because it is going to be concave up. So let's go ahead and look at a Desmos graph of the function. So here you can see that at negative 1, at 1 minus square root of 2, we have a relative max. At 1 plus square root of 2, we have a relative min. All right, just a graphical verification.